Okay, today we're going to look at modeling, solving one-step equations. And we're going to look at the first equation where the variable, let's just say we're going to use the variable k, and whatever k is, we're going to add 4 to k, and then the result is going to be -2. So whatever the number is for k, we're going to input some value for k, add 4 to it, and then we got -2 coming out on the other side. So we're going to use two methods to help us solve. And I'm going to start with the first one. I'm going to call this opposite operations. Opposite operations. So let me clean up that O there. So doing the opposite is going to help us work a problem backwards when we are missing a variable. So opposite operations is one strategy. The other strategy is just looking at the equation and asking yourself a question. What would we need to add 4 to get us to -2? If we have positives, we have 4 positives, and we need a result of negatives, well, then we know the question mark, we need to have more negatives on the left side to get negatives coming out. So when you're asking the question as far as the first one, we could say -4 plus +4 would give us 0. So -4 would get us to 0, but we need -2. So we're probably going to need more negatives than -4 to get us to 0. So if we put in -6 plus +4, well, 6 negatives would give us a negative result coming out if we put in 6 negatives with 4 positives. Okay, so that's more of just the guess and check method. And we are actually going to look at the opposite operations method here. So on the left side, we have 4 positives. Okay, and now if we do the opposite on the left side of 4 positives, we're actually going to do that equally on both sides. Okay, so on the left side, we had 4 positives. In order to think this problem backwards, we're going to do the opposite on the left side and the right side in order to work this problem backwards to get to the k. Okay, so if we bring in 4 negatives on the left side and we bring in 4 negatives on the right side, so we treated both sides equally. And now what we're actually going to do is pair these up, highlight all of them, and then on the right side, there's a little button called 0 pairs, and it's going to pair them up. +4 and -4 will disappear. Okay. Okay, and so that was kind of quick. I'm going to model another way here, and then we'll come back to that method for solving. Okay, so let's think about this here just for a moment. So if we bring in 6 negatives, let's try it this way. Okay, so we bring in 6 negatives, and when we bring in 6 negatives, we're going to take the variable away. Okay, we're going to take the variable away because now we have a number, and let's say this is -6, and we're going to check and see if this is true. Okay, so we've got -6 and +4 on the left side. Okay, so we took the variable out and we put a real number in there. All right, so we're going to try these opposite pairs again. So you have positives and negatives together. We have 6 negatives, but we have 4 positive. But when we pair these up, we're going to go ahead and make the 0 pairs. Once you click them, positive, negative, those are all going to delete each other. And then if we put the correct value in here on the left side as -6, then it's going to say -2 is equal to what we do want coming out. So we put in -6, the process worked itself out, and we're left with -2. So we had a good answer here. Okay, so I'm just going to look at a quick example here. Now, let's say we didn't guess the correct answer to put in there for the variable. So instead of -6, what if we put in -7? So -7, if we put it in there, -7 plus 4. So we have our positives and negatives. We make 0 pairs with all of those. And those delete. Okay. Oh, I think I had clicked over. There was extra on top of that. And so this is -3 is equal to -2. That is not true. We have too many negatives on the left side for this to be equal. So this was not a solution. Okay. So we're going to take this back out and put -6 back in there. And that would make this solution true where -6 does equal -2. Okay, so now I'm going to go back to the original equation where we have some number k plus 4 is equal to -2. And so this here deleted. I'm not sure that I deleted. Okay, so k plus 4 equals to -2. All right, so now we're going to use this opposite operation idea of subtract 4 on the left side to cancel that out. And when we subtract 4, then those are both gone. And then we do it equally on both sides. So if we subtract 4 on the left side and the right side, then this process over here will give us the value for k. So then we have k equal to some value. And let's take a look at that. So we subtract 4 from this side over here. And equations, we're going to keep them balanced. So if we do that on the left side, then we will subtract 4 on the right side. The left side, that makes 0 pairs. And so now we have our answer where k, or our x variable, is our solution. So just quick solving using opposite operations. This k, the answer is going to be k is equal to -6, would make this equal. Okay, and so now taking a look at our equation, balancing it out. So on the left side, we have -2, and on the right side, we have -6. So we need to think about how do we go back, think backwards with -6. How do we go from -6 to get us back to -2? Okay, so just looking at this, if we have -6 and we need to go opposite operations, we're going to have to take away two negatives, and that tells us that we must have -1, -2, -3, -4 on the left side in order to be equal to what we have on the right side. Okay, so how do we model that out? Well, in order to take away negatives, we're going to have to bring in positives to take those away. And if we take away 2 on the left side, then we're going to have to take away 2 on the right side. So what does that look like right here? So basically we add 2 to the left, and then we add 2 to the right, and then we make our 0 pairs, pair those up, and then on the right side we add 2 negatives, 2 positives, we pair up those negatives and positives, and that's where our canceling comes in. So the negatives and positives cancel. Now we're left with the variable b, and we're left with, we bring in 2 positives. These are opposites, they cancel. So we are left with b, the variable, is equal to 4. Negative 4. Okay, so now we went through an adding and subtracting example. So now let's take a look at a multiplying example. So let's set it up. So let's say we have 2w is our variable, and we need to get two of them. So we're going to put 2w, and then we got 1, 2, 3, 4, 5. And so that two rows of 5 would give us 10. So 2w, so this variable is multiplied by 2. And so we need to figure out how much is just 1w here. Well, we could ask her, we could do some mental math here and just ask ourselves 2 times what equals 10. And so we could tell ourselves that 5 and 5 over here, 5 and 5 together would equal 10. But modeling that out, let's take a look at how that looks. So if we have numbers grouped together and it's multiplied 2 times w, and then we have 10, but we need to think about the opposite of multiplying. Multiplying is going to be making more groups, and then unmultiplying is going to be separating groups, separating into equal groups. And we call that dividing. So the opposite of multiplying by 2 would be dividing by 2. So if we take our two groups and we divide them into equal groups, then we're looking to see what is in each group. So mathematically on the bottom, so what we do is we take the 2w, divide that by 2 in order to cancel out the groups. And then if we divide the left side by 2, we divide the right side by 2 also to get two separate groups. So then in each group, we have x is equal to a value. The 2 divided by 2 just becomes down to one group, or 1w, and then we can see that each one is equal to 5. So that value where w equals 5, so you put it back in there as the input. 2 times 5 does equal 10, so that checks out. Okay, all right, I'm going to go through this example and then one more after this, and then we'll get to the independent practice. So on the left side, we have negative 3p, or just to use longer ones. So we got negative 3 variables, and then whatever number we put in here is if the variable on the negative on the outside, whatever number we put in here, it's going to be switched to a negative. It's going to be multiplied by a negative. Okay. And then the variable on the right side, or the value on the right side, is going to be negative 6. So we need to put something in here that's going to multiply negative 3 to give us negative 6. Right? So we have negative 3, negative 3. Okay, and so we're thinking about opposite operations in order to solve here. So we have negative 3 multiplying the variable p. So we need to think about what's the opposite of multiplying by negative 3. And so we go up here and then we start separating into three groups, into three negative groups. Okay. So now that we separate them into three groups where we just have one variable equal to something on the other side, and we see that whatever x is, negative x is equal to negative 2. All right. So mathematically, let's do that down below. Divide by 3, divide by 3, and then the 3 and 3 will cancel, and then we have p, but we have the negative on the outside. So whatever number we put in for the variable is going to be the opposite of what we should be putting in there. So we need to get rid of that negative on the outside as well. So all we do that is just divide by a negative as well on both sides, and then that will cancel. So now we just have the variable p, which we want it to be. So then we know what p should be to put in there. So 6 divided by 3 is 2. and then the negative divided by negative would be positive. So what this is saying is we just take a regular 2, put it in there for x, and because there's a negative attached to that variable already, then that will switch that regular 2 into negative 2, negative 2, negative 2, which means it would be equal to what is on the other side. And remember, we don't always put the positive sign in there. We just assume that it's positive if there is no negative sign in there. So this situation, P would be equal to 2. Okay, last example for the modeling. So on the left side, we have 3 negative variables, or negative 3 times m, which is equal to positive 9. So just question mark, negative 3 times what? Negative 3 times what would give us a positive coming out? So the only way to change a negative into positive would be multiplying by another negative. So we know negative 3 times negative 3 would be the way we're going to have a positive 9 coming out. Okay, so let's just put that on hold for right now and then think about opposite operations. So the opposite of multiplying the variable, the opposite of multiplying this variable by a negative 3 would be dividing the variable by a negative 3. And in order to solve equally for the equations, we're going to divide both sides by the same thing. So 3 divided by 3 will give us 1. The negative divided by a negative would change that into a positive. So 9 divided by 3 is 3. And a positive divided by a negative is going to switch that positive back into a negative. Only when you have double negatives would you have a positive answer. So what that's saying is if we put in negative 3, negative 3, negative 3, that is the only way you would have positive 3, positive 3, positive 3 coming out. Because these double negatives, the negative variable would switch what you put in as the input. Okay, so let's model that out. We're going to model that out and see what's going on. Okay, so let's separate these equally. Separate them into 3 groups. Okay, so we just separated them into 3 groups. And now we're going to highlight all of them. Oh, we can't see all of it. Let me bring them down. We're going to highlight all of them. Now let's think about this. On the left side, these are all negative variables. So in order to figure out what the positive variable is, we would actually, no, we can't even do that. So we separate equally into 3 groups. And so we know negative x is equal to positive 3. Negative x is equal to positive 3. Oh, I think we can here. There we go. So negative x is equal to positive 3. So if we change that to a positive x, the positive x is the inverse. So what's equal to on the other side would be the inverse. Okay, let's try that again. Okay, so when we separate this equally into groups, divide by 3. So that means negative x is equal to positive 3. But whatever we put in there, the negative variable is always opposite of what we need it to be. So if you have a negative variable, if we flip the sign for the variable, we flip the sign for the other side. Now that is our answer that is true. So x is equal to negative 3.